So in this question, first of all, the mass of Arjun is doubled. Before the mass was doubled, the gravitational force between them can be given by the formula F is equal to capital G m1 into m2 upon d square. Now this particular thing is equation number 1. Now mass of Arjun is doubled, that means m2 is doubled. So we just need to change the value of m2 and make it 2m2. So now F dash, or we can say F1, that is the new force, will be equal to capital G remains as it is, m1 remains as it is. Instead of m2, we write 2m2 upon d square. Now what we can do is, we can take this 2 and shift it towards the left hand side. So now what we'll do is, we'll write 2 g m1 m2 upon d square. So that means, as you can see, g m1 m2 upon d square remains and 2 remains. So here what we know is f dash. Now this g m1 m2 upon d square is nothing but the value of capital F. So 2 remains as it is, but g m1 m2 upon d square becomes F. That means this entire force, or the new force, actually becomes twice or 2 times. So this is the answer for this, that force becomes double. Moving on to the next, it says the distance between them is doubled. This time the distance is doubled. Initially F is equal to capital G m1 m2 upon d square. But now since the distance is doubled, so in the equation number 1, what we'll do is, g m1 m2 remains as it is. We need to change only the value of d. But here we have d square. That is why we need to put 2d the whole square. 2d the whole square. If we do not put the whole square, whole sum will be wrong. Now the square of 2 is 4 and the square of d is d square. So we have 1 upon 4 on the outside. So we get 1 upon 4, g m1 m2 upon d square remains as it is. Now again we know that g m1 m2 upon d square is nothing but the value of capital F. So 1 upon 4 remains as it is. Instead of g m1 m2 upon d square, we write capital F. So this time the force becomes 1/4.